Welcome to solverfy.
This is the answer to Chapter 15, problem number 60 from the Smith Organic Chemistry textbook. And this problem is asking us to draw the two steps of propagation in this reaction of the hydrochlorination of an alkene. And it's asking us to calculate the energies of each step and using those calculations to determine which of the two steps prevents the indefinite propagation of this reaction from occurring. So for step one, we have this carbon-carbon double bond breaking, and that takes 267 kilojoules per mole to make that happen. And then we also have a carbon-chlorine bond forming, which releases 339 kilojoules per mole. So when you add those two numbers together, 267 and negative 339, the result is negative 72 kilojoules per mole. So that means that step one is exothermic. So that's going to be favorable because it's releasing energy. So we know that it must be step two that prevents the indefinite propagation. But just to be certain, we'll calculate the energies there as well. So for step two, in the first part, you have a hydrogen-chlorine bond breaking. This requires 431 kilojoules per mole. And then you have a carbon-hydrogen bond forming, which releases 397 kilojoules per mole. And so when you do the math there, you see that this step requires 34 kilojoules per mole in order to occur. So this is an endothermic step, step two. And so basically that means that we have to put energy into the system in order for step two to occur. And since step two is endothermic, it's not favorable and it's not going to just spontaneously occur or continue to occur. And so step two is the step that prevents indefinite propagation. And again, we can tell that because it requires energy. It has a positive number for its delta H naught. And so that means it's endothermic and it needs energy, and it therefore is not spontaneous. And therefore, it is the step that prevents indefinite propagation of this reaction. And that is the answer to Chapter 15, problem number